January contest, the mainly the bronze questions. So first, if you didn't do the USACO past January contest, that's also fine. Um, but also as a disclaimer, uh, the contest results aren't posted yet, so I'll explain that later. But the next contest is February 26th and March 1st. I'm pretty sure February 26th and March 1st. I'm pretty sure that's yeah, it's Friday to Monday again. And then there's more info on their website, right? So yeah, okay, the contest hasn't ended. But that's the next contest, is the third contest. Note the contest after the third one, the fourth one, which is also the last one of this 2020-21 schedule. This one's the US Open, which is notably a bit harder than like December, January, and February contests. So that's just a heads up. Although they promote based off cutoffs, so it still shouldn't make like too much of a difference per se. But as you can see, the reason why I said disclaimer earlier, because the contest results are still being like compiled and they'll be posted shortly, which basically means that one, we can't access any of the questions from the January contest, but we have screenshots, so that's okay. And what else it means is that we can't run any of the code against their grader, right? So like normally in the past you can run code against the grader and log in and use the analysis mode. And because like we didn't none of us like actually like took the bronze contest in January, most of us took the silver one. So the code that I'm gonna be showing today, I'm not 100% sure if it's gonna work like for all the test cases, although I'm pretty confident, but like I haven't tested it yet, so there's like no proof, or so there's no way I can validate that. But so if any of you guys have done the past contest or noticed like a bug or something, just feel free to let me know, because it's likely there might be like small bugs here and there because it's not tested yet. But anyways, this is the first problem, or at least I think this is the first problem. I also believe it's called Uddered But Not Herd. Um, Basically, we'll quickly skim through it. So this is the first question. It's a problem statement, right? So it says a little known fact about cows is that they have their own version of the alphabet. So it's called the calphabet, and it also consists of 26 letters A through Z, which is pretty good. But then when a cow speaks the alphabet, she lists these letters in specific ordering that might be different from the order that A B C D E F G, right, that we know and we are used to hearing. And then to pass the time, Bessie the cow has been humming the cow alphabet over and over again, and Farmer John is curious how many times she's hummed it. And then so now it's like the actual stuff. Given a lowercase string of letters that Farmer John has heard Bessie say, compute the minimum number of times Bessie must have hummed the entire alphabet in order for Farmer John to have heard the given string. Farmer John isn't always paying attention to what Bessie hums, and so he might have missed some of the letters that Bessie has hummed. The string you are told consists of just the letters that he remembers hearing. So that part's important. He only remembers hearing like some certain letters, and we have to work based off that. Input format, 26 lowercase letters A through Z in a random order that they appear in the alphabet. And the next line is the string of lowercase letters that Farmer John heard Bessie say. Its size is from 1 to 1,000, so it's not that bad. 1,000 is like very doable. And then you need to print the minimum number of times Bessie must have hummed the entire alphabet. So this is a sample input. You're given the ABCs regularly. This is a alphabet. And then what Farmer John heard Bessie hum was MOOD, right? And then your output would be 3. And it also explains why the output is 3 for this one. Um, this part is non important. We just look at these 3 here, right? So the first time humming going through, the capital letters are what Farmer John heard. The first time Farmer John heard M and O. The next time Farmer John heard O. And then the last time he heard D, right? So MOD. And so we notice, like, first thing is that M and O appear in the same like sequence in the same time, and that's simply because O comes after M, right? Because O comes after M, it's possible for Farmer John to have heard Bessie hum O M and then O immediately after without like humming a whole new sequence of the alphabet. And then if it's the same letter O and O, it doesn't work out because you can't have multiple letters or like the same letter in your alphabet. You have to hum it a whole nother time. And then the last case, which is also similar to the previous case, is if the letter D, right, is like before the letter O, right? So if it's before in the alphabet than the letter previous, so D and O, then it has to have hummed a whole nother time because there's no way to have heard D come after O without restarting the alphabet. And so based off like those two rules basically, right? So if it's before or after the previous letter, I can write a program kind of based off that. So I'm gonna pull up my Eclipse. This is just a Java. It's an IDE editor. It's for Java. It's pretty good. Um, this is the code I have. So we create a scanner. We take in the input. The first line is the alphabet. The second line is what you heard hum, and then we need to count, right? So we start the counter at one, just start the counter at one, because the first humming is the first sequence, and then this part's important. We're gonna write a for loop, right? And we wanna look over every single character. However, we wanna start our for loop at I equals 1 instead of I equals 0, mainly because we don't wanna check the very first letter because no matter what the first letter is or the first character Bessie hums, it doesn't matter. It's going to be the first sequence, like because there is nothing previous to check it against. So that's why we start at one, and then we're gonna end at hum.length, right, which is a string, and I plus plus. So first thing we do is we grab the current letter or the current character in a string. We can do a substring. Hum dot substring I and I plus one, right? Those are positions. And then we do the same exact thing except we call for previous, which is also a string. And instead of I and I plus one, we just do I minus one and I. So that'll give you the previous character at this position. This give you the current character at this position, and then we just if statement. So if calphabet dot index of the string is less than or equal to calphabet dot index of previous, counter increases. Yeah, that makes sense. Yeah, it's correct. Counter increases, and then counter, right, starts at one, and after looping through the for loop, we print out counter. Um, this should run under time because it's basically like O of n, I think, and it's like 1,000, so it should run well within time. There are some notable things. You can't really improve the program too much, except stay away from strings. We don't like using strings. Using strings in code normally take a lot of time because strings are immutable. So when you do stuff like substring or whatever, or sometimes it might like take a bit more time if you're like doing numbers. So we can run the code actually. So let me pull up the console, and then all right, you guys can see it. This is our console. So let's run the code. Oh, oh shoot. It's not in the main class. Wait, actually, give me a second. Let me pull up via VS Code, and it should work, I think. So this is my VS Code. It's the same thing. It's the same exact file. Everything is identical. Same comments and everything. Let's check if this works. So I also try running this via the console. Okay, so then the first thing you want to input is ABCs, ABC. All right, so that's the ABCs. And next thing you want to enter is mood, right? That was our input. And it gives us 3, so it works. So yeah, this code does work basically. I have another method. It's very similar. It's just we're using an array list of characters this time because it's a bit better. Basically, all we do is this long statement. I got off Stack Overflow. It creates an array list of characters based off the string. So what it does is it takes in the also sorry, this also uses a fast reader. So up here, this is a fast reader. This is a static class for it. Basically, it's just a buffered reader and string tokenizer implementation instead of your scanner, and also in a method where you don't have to like keep on calling the string tokenizer, so it's a bit more usable. It doesn't really matter, but it's a fast reader. And then this scanner, oh, this should be commented out actually. All right, that was bad. Sorry about that. And then so the first thing we take is we take the array list of characters. And then how we map it is we take the in.next line, which is a string, and then we need it into chars, and then there's a map to object, which basically maps every single e is like each object, so it maps every character from in.next line to the collection as a list. Yeah, and it's a bit confusing. I'm not even sure how it really works, but I got off Stack Overflow and it does work. And then so now we have an array list of characters as our alphabet. And in this time, instead of taking hum as a string, we're going to take it as a character array because character arrays are more usable than strings. And then everything else is exactly the same, except this time it's a character and we're calling it via an array element instead of a substring. And then we're using index of with an array list instead of a string. So I think this should run a bit faster, not noticeably faster, but a bit faster. However, it's important to note that we are sacrificing a bit of time in the beginning for pre-processing. So pre-processing is like the thing where you like first you modify the input, the given input to like in a format where it's a bit more usable. So you waste some time there to gain the time back later. But it shouldn't make too big of a difference because the algorithm or whatever you want to call it is very straightforward. And then so that's the first question, should work. The second one's even more odd photos. This one could be arguably the hardest question from the past contest. So I'm gonna skim through the problem statement this time, but basically each cow has an integer breed ID from 1 to 100. And if Farmer John has an idea, he wants to partition all the cows into disjoint groups. So each cow in exactly one group, and then line up the groups so that sum of the breed IDs of the cow in the first group is even, then the second one is odd, then the third one's even, and you keep on alternating. And you want to form the maximum number of groups. And the input is pretty simple. You're given first n, which is the size of the numbers or how many numbers they're giving you, and you get each number. And then, so if you're given 7 and 1, 3, 5, 7, 9, 11, 13, the maximum way to form groups is 3. You can place 1 and 3 in the first group for 4, right, which is even. 5, 7, and 9 make up 21, which is odd. And then 11, 13 is 24, which is even. The second sample input 7, 11, 2, 17, 13, 1, 15, 3. Same thing, you can have 5 groups this time. You place the number 2 in the first group, 11 in the second group, 13 and 1, which is 14 even in the third group, 15 in the fourth group, that's odd, 17 plus 3 is 20 in the fifth group, which is even. This one's a bit trickier. First thing you should notice is you want to maximize number of groups, right? So that means you want to put as little numbers per group as possible. And then second thing we need to notice is that it doesn't matter what numbers they give us. All it matters is if it's even or odd. In this case, all our numbers are odd. They could have given us 1, 1, 1, 1, 1, 1, 1. It's like 7 ones, and we would have still got 3. They could have gave us 7 99s, and we also would have got 3. It doesn't matter because we don't actually need to deal with the numbers. We just need to deal with if they're even or odd. And then the last thing we should notice is that to form an even number, you can either get an even number, right, which is pretty simple, or you can get 2 odd numbers, right? So 1 plus 1 is 2. 2 odd numbers form an even number. And then the ways to grab an odd number is either you have an odd number or nothing else. There's no way to form another odd number with making up with only even numbers. It just doesn't work out. And it doesn't make sense to add an even number to an odd number to form an odd number because you're just wasting an even number at that point. So that's what we're going to work off. So this is our code. We're running a while loop. We can optimize this a bit better, but it was too confusing for me to do it. So basically, first thing we do is we use a scanner. We grab n, right, which are the number of numbers that are going to come. And then we initialize 2 variables, even and odd, both to 0. And then after initializing, we run a for loop to grab each n numbers. And then we check if it's even, we increment even. If it's odd, we increment odd. And then so after running this for loop, we have grabbed all of the input and we have stored how many even numbers and odd numbers there are. And now we need to do like the actual algorithm. So it's a bit long. This is casework. So counter is 0. Counter is the amount of groups we're going to make. So each time we can form a new group, we're going to increment counter by 1. And then so we're going to have a while true. So this is going to keep on looping infinitely until we break. There are 2 break statements. We'll get to those later. So first thing we need to do is check if counter is equal to, if counter mod 2 is equal to 0. Counter mod 2 is the same thing as if counter is even. So if counter is even, that means we currently need an even number. If counter is odd, right, else statement, we need an odd number. And then so if counter is even, we need an even number. So first we check if we have an even number, right? So if even, which is up here, is greater than 0, then we're going to subtract 1 from even, decrement it, and then we're going to increment counter. And then we'll move on. If, however, we don't have any more even numbers, we need two odd numbers, right? So let's grab two odd numbers. So if odd is greater than or equal to 2, we're going to decrement odd by 2, and we're going to increase counter by 1. It's straightforward. And then there's another case where we don't have two odd numbers. Instead, we have less than two odd numbers. So we either have one odd number or zero odd numbers. Yeah. Wait, no, it won't be 0. Basically, we only have one odd number. And so if we have one odd number, we're stuck in a predicament, right? Because what this means is we need to form an even group. However, the only thing we have left is we have 0 evens and we have one odd left. And there's no way you can form an even group. So we need to actually decrement counter. Oh, I don't know why I did minus equal 1. All right. We decrement counter by 1, and then we need a break. The reason why we decrement counter is actually because um, so if we look at our notepad, right? So let's say we have a group of the 2, right, even, and in partition we have a group of 1, odd, and then now we need to make an even group, and the only number we have left is a 1, right? So there's no way you can put a 1 here because this would be even. So instead, if you want to try putting it here, it won't work either because this would also become even, right? So then we have an issue. So where does the 1 go? Right, it's actually a good question. Where does the 1 go? Wait, I think this one's not feasible. Actually, it is feasible. So basically, what this means is there's no way you can form two partitions. You can only form one partition, which is 4, a partition of size 4, right? Because you have 2, 1, 1, and one partition like that. And so that's basically what we're doing when we decrement counter by 1. So yeah, it's kind of confusing. But the way you think about it is when we reach this point here, we have an even and an odd, right? And then we have a blank right here where we want to create an even group. However, we only have one odd number left. The only thing we can do is decrease the number of partitions we have by 1. So instead of 2 partitions, now we only have 1 partition and we break. Because basically what you need to do is you need to combine this odd partition and combine the last odd number to make a bigger even number as the last partition. Yeah, that's like the key to it. It's very confusing. And so if you guys have questions, you guys can let me know. And then for the odd one, it's much simpler. If we do have an odd, decrement odd, increment counter. And if we don't have any more odds, there's nothing we can do, so let's just break. And so this should work. Um, I heard from the unofficial USACO Discord that it has a edge case, but we won't be able to know because we can't really like test it against any edge cases. So Java on. So let's try to input statement, right? So 7, 1, 3, 5, 7, 9, 11, 13. It gives us 3. Was that correct? Okay, nice. So it was correct. And then we can test out the new partition thingy that I was just talking about. So hopefully it works. So we'll give it 3 numbers. We'll give it 1, 2, 1. And it gives you 1, right? Which is what we were showing here. And so this code should also work. Yes, you can make this code better. You don't actually need this while loop. You can just do some math after given the even and odd numbers, like mod 3, both of them. And yeah, that's basically the answer. Um, so now we're gonna talk about the last problem. It's called just stalling, I believe. Just stalling. This one I thought was kind of hard, but that's because my math was kind of bad. But this question is actually a math question. So we're gonna look at it. Farmer John has n cows. Heights n is between 20, of heights of whatever, right? And then his barn has n stalls, so each cow has 1 stall, with max height limits of whatever. And then basically, obviously, a cow can only reside in a stall if the stall is tall enough for it. And then how many ways can Farmer John arrange his cows so that each cow is in a different stall, and so that the height limit is satisfied for every stall. So we're gonna skip input format because it's a waste of time. This is a sample input, right? So it gives you n. So if n is 4, that means we're going to get 4 numbers here, which represent cow heights, and 4 numbers here, which represent stall heights. So in our sample input, we have 4 cows. Cow 1 is height 1, cow 2 is height 2, cow 3 is height 3, 4 is height 4. We have 4 stalls. Stall 1 is height 2, stall 2 is height 4, stall 3 is height 3, stall 4 is height 4. Sample output, the answer is 8 because we cannot place the third cow into the first stall because 3 is greater than 2. We cannot place the fourth cow into the first or third stalls because 4 is greater than 2 and 4 is greater than 3. So we need to figure out how many different ways can we fit all of these cows into different stalls without like putting, how many ways can we fit 4 cows into 4 different stalls without like the heights not working out. And so it's a math question. First thing we need to do is figure out the number of cows that can fit into each stall, right? So why do we need to do that? We'll explain that later. So first, let's look at our code. We create a scanner, we grab n, we initialize 2 arrays of length n, we create 2 for loops to store the input of n numbers, right? And so that's all input stuff. And then now we have another new array. It's called results. Results is basically where we're going to store the number of cows that can fit into each, no, no, sorry, the number, yeah, the number of cows that can fit into each stall, right? So results of 0 would be the number of cows that can fit into stall number 0, right? Same thing. And then now to check that, we're going to run a double for loop. There is a better way to optimize it, though I'm not going to show it because it's confusing and I'm not sure if it works yet, but there is another way to optimize it. So the first main for loop, this outer loop, is to loop through each stall. The second inner loop is to loop through each cow. So for each stall, we're going to loop through each cow to check if each cow can fit into that stall's height. And if it can, we're going to increment results, right? So to make this make sense, we're going to let's print out results really quickly to show it. Arrays dot toString results. And then let us not print out the, oh, it doesn't matter. Oh, we do have a problem, right? It's not gonna work in here. Yeah, also if you're curious why I can't run the code in Eclipse and you're thinking like, wow, Eclipse is a bad editor, it's because I renamed some folders and then the main method, uh, what's wrong? Wait, why does arrays.toString not work? Okay. Does anyone know why that doesn't work? That should work, right? Wait, what? Okay, but the reason why it doesn't work in Eclipse is because I messed up some main. I reordered some functions. Huh. Okay. So we're not gonna print it out because it's acting up. Yeah. So basically, we can print out via Notepad. So if your input was 4 1 2 3 4 2 4 3 4, it would simply have been, so 4 1 2 3 4 2 3 2 4 3 4. And then what you would have got is you would have got how many cows can fit in each? Oh, you would have got 2 4 3 4, I think. For results, results would have been 2 4 3 4. Yeah, that makes sense because 2 cows can fit into stall number 2, right? 1 and 2 can. Every cow can fit into stall number fit into the stall of height 4, so there's 4 and 4, and then 3 cows can fit into stall height 3. Okay, that's kind of unnecessary, but those are your results, and then this is what the array of results is. So it's also 2 4 3 4. It's not going to always be the same as stall heights, but doesn't matter. And then after we get the results, we need to sort the results because this is where the math comes in. Um, if you have like n is 4, and if you have 4 options, and you have x amount of cows that can fit into stall number 1, y amount of cows that can fit into stall number 2, and then z and then a, basically you can't just multiply x by, times y times z times a. You can't just multiply 2 times 4 times 3 times 4. That will not give you 8. Well, you want to get 8, right, from these numbers. The reason why I won't give you 8 is because, so if you have 4 stalls, right, if you have 4 stalls, and then you have 2 options for this first stall. So let's say you put stall cow X here. And then now you also have 4 options for this stall, right? But that's actually not true because you already put 1 cow in stall number 1. So you can't put like that same cow here. You can't put X here. You can only put Y, Z, or A. Because you already put that cow into X. So let's say you choose Y. And then for stall number 3, although it says you have 3 choices, oh, okay. The reason why we need to sort it is because we need to go from smallest to greatest, right? We need to go from the smallest amount of cows that can fit per stall into the greatest amount of cows that can fit per stall. So it goes 2, 3, 4, 4, right? This is it sorted. And then so you have 2 choices for the very first one. So let's say we choose X. Now you have 3 choices for the second one. However, you already used one of them from X. The reason why I'm saying you already used one of them is because for a stall with a height of, if stall B is greater height than stall A, um, every cow that can fit into stall A can also fit into stall B, right? So if stall A's height is only 3, but stall B's height is 5, and if 2 cows can fit into stall A with height 3, then those 2 cows can also fit into stall B with height 5, plus some more cows, right? So that's why you don't have 3 choices here anymore. Instead, you have y minus 1 choices. You have 3 minus 1 choices. And for this one, instead of instead of y, let's just put 3, right? So we just grabbing from top 2, 3, and then 4. So now it's the same thing. Instead of having 4 choices, you don't have 4 minus 1, you have 4 minus 2 choices. And then for the last one, instead of having 4 choices, you have 4 minus 3 choices because you've already used 3 cows previously. So what you would do is you multiply 2 by 3 minus 1 is 2. 4 minus 2 is also 2 times 1, which gives you 8. And so that's the math part of the algorithm. And then so that's how we sort our results. And then this is our answer. We're going to multiply answer. Note we're initializing it as 1 instead of 0 because we need to multiply it, and you multiplying by 0 gives you 0. And then for loop, we're going to loop through everything. And then we're going to multiply the answer by results of I, subtract I increments. So when results of I is the first element, it would just be subtracting 0. When it's the second element, it will subtract 1. Then I'll subtract 2. Then I'll subtract 3. And you print out the answer. We can test this to make sure it works. Java just stalling. Input is 4, 1, 2, 3, 4, 2, 4, 3, 4, and the answer is 8. So that's the algorithm for the last question, and it should also work. Now we have like 5 minutes left, so we have a couple options. If you guys have questions, you can let us know right now. I think we do. Josh, how long would it take you to cover like a silver problem? Is 5 minutes enough? Probably not.
For question 3, maybe.
Okay, you wanna just try doing it then?
Sure.
Here, I'll send you the picture. Uh, Let me stop sharing. Um, Give me a second. Let me grab the picture. You want question 3, right? Spaced out?
Yep.
Okay. I'm gonna send you a PDF. Okay, I just messaged it to you. So heads up, the PDF that Josh is looking at or is gonna show, it's not mine. I didn't get full points for spaced out. Uh, yeah.
Mhm. Right. AI. So here is the question spaced out. So spaced out is a bit the question asks a bit weirdly, but the essentially what it says is that this farmer John, he wants to take a picture of his cows, and then he can put his cows. So there's they give you sort of a field to put the cows on. And the thing is that when you put down the cows onto the field, they have to be in a way so that every single 2 by 2 square. So for example, you have these two C plus these two dot beneath them. They have to contain exactly 2 cows for every 2 by 2 square. They have to have exactly 2 cows, and no more, no less. So then, yeah, and then after you have all the cows out, um, the question is that what is the maximum number of beauty points? So beauty points are calculated by what number the cows are on. So when they give you a field, this is a 4 by 4. It's kind of it's broken in the middle, but it didn't look like that on the test. But basically, this 4 by 4 field, once you put all the cows on there in a way where every 2 by 2 square, like this 2 by 2, this 2 by 2, this 2 by 2, and so forth, has exactly 2 cows. You add up all the numbers that the cows are sitting on, and after you do that, you add them up and you try to get the maximum score. So once you add up all numbers, that's called the score, and you want to get the maximum score, and you want to print out what the maximum one is. So in this case, for the sample solution, if you put the cows in this sort of pattern where if you look at it, every 2 by 2 square has exactly 2 cows in them, whether it be the middle, the side, the top, the left, something like that. They always have 2 cows. And if you orient them in this way, you'll add up these two numbers, these two numbers, these two numbers, and these two numbers, and it gives you the maximum number of points. So that answer is 22. So first of all, when you're approaching this problem, you want to look at it and see how, first of all, what sort of pattern would it, how do I explain this? What sort of pattern would this result in where you have every 2 by 2 square has actually 2 cows? Can you find any pattern within that statement? So if you think about it, you could start trying to draw maybe some scenarios. You have the scenario they provide you with where it's like C, 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 dot, 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 C, C, C. And maybe there's another scenario down here where it's C dot C dot C dot and C dot C. We also have their solution example down here where it's basically C, C dot, 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 C, 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 C dot, 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 C, C. And it's poorly drawn, but anyways, if you have a eye for seeing patterns, why is it not scrolling? If you have an eye for seeing patterns, you'll realize that how you could form these things is if either the rows or the columns. So in this case, this is the columns. This one's the rows. This one is columns. If they alternate between cow and no cow, they'll result in a pattern that will have every 2 by 2 square having 2 cows. So it doesn't matter if you do it by columns or do it by rows. If one of them has them in alternating pattern every single time, cow, no cow, 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 no cow, 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 no cow, 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 no cow, cow, no cow, and so forth, then the resulting pattern will always be 2 cow in every 2 by 2 square. So once you have that down now, you know that either the rows or columns have to be alternating between cows and no cows. How do you find the maximum score? Well, this is pretty simple. So um, we have two scenarios. Either they could be alternating in rows or they could be alternating in columns. So let's look at alternating in rows first. So cow, no cow, cow, no cow, cow. This is one row. And if you when you're looking at one row, there's two different ways to alternate. You got to do cow first, or you could do no cow first. So there's two different scenarios when you're looking at a row for one row. And well, what you do is it's pretty simple to calculate both of these, the sum. So for the first one, you just grab your line and you alternate within either the first number, the third number, the fifth number, and you add them together and you get the sum, and we call that sum one. Then you get the sum of the second number, the fourth number, the sixth number, and so forth, and call that sum two. And you just compare which one is greater than someone or some two because you want the max score. And say someone is greater because it has more numbers, so it's more likely to be greater. But you could just compare using like if someone is greater than some two, then you would store someone into your total. And since, if you remember, the pattern, whatever your row one is, the row two pattern is independent from row one. So row two could be either maybe like no cow cow, or it could start with cow no cow. It still fits the pattern. So each row is independent from each other. So you just repeat this process for every single row, and you adding the biggest one of the two different case scenarios for each row to the total. And after that, you repeat the same thing but for columns instead. So now you say maybe they alternate in columns, and you calculate the maximum for each row, and then you add them together, you add that to the total, and that final sum would be the maximum amount of points. So yeah, actually, hang on, no, my bad. So you say this one is total 1, the column will be total 2. Then you compare the two totals and pick the greater number. So either the columns will be more or the rows will be more, one or the other. And whichever one is more, you output the sum, and that is your answer. So it's kind of a pattern recognition one. If you can recognize a pattern, it's pretty easy. If you don't recognize a pattern, when you try to bash it, it'll be really, really, really hard. So yeah, patterns. Any questions? No, no questions. Cool. Yeah, so now it's 110. So
Yeah, that was just heads up. That was a silver 3 question from January contest. I think we're gonna end the meeting now because I think we're good on questions. And if you do have a question later, you can always message us. But I'm gonna end the meeting.